Okay, I'm going to start talking about a couple things regarding what's called the basic counting principle, combinations, which we talked about, the formula the other day, and then permutations. So the counting principle, or we might call the multiplication principle, finds the number of ways several independent events can occur. We also, sometimes I'll refer to it called the slot method. This is for dependent events. We can go ahead and we can multiply for the slot method. And this is when we order things. So the first example I'm going to do is if I have, it says there are 6 flavors of yogurt. We have 6 flavors of yogurt, 4 types of granola bars, 5 different juices to choose from. And then it says, how many different breakfasts could I eat if I chose one of each? So this is the counting principle, or I could say it's the basic multiplication principle. All I have to do is go ahead and just multiply 6 times 4 times 5. And we can use our scientific calculator, or we can do it in our head. We have 100 different breakfasts that we could choose. Now, the next type of problems we have license plates problems, phone number problems, and I like to do what's called the slot method with these. So it's going to say how many different license plates are possible that have 2 letters. So I'm going to go ahead and I'm going to do 2 slots for letters. The first of which is a Q, followed by 3 digits, 1, 2, 3, with no repetition. So the first thing we have to think about is there are 26 letters in the alphabet. And then we have 10 digits, which we are going to use 0 through 9. So if the first letter has to be a Q, okay, so for this first spot, I only have one choice. It has to be a Q. So that's going to be one choice. Now my second spot, it says I cannot repeat. Yeah, it did say I can't repeat, no repetition. So that means I used one letter from the alphabet, so I have only 25 letters left. Now for the first slot of digits, I have 10 choices. Let's say I used a 1, okay, the number 1. Now I'm going to have 9 choices left, and I would have 8 choices left. Now for all of these, you always multiply. And so then you would go ahead and you would multiply in your scientific calculator, and when you do that, you get 18,000. Now your next one, it says 2 letters followed by a 4-digit even number with repetition allowed. Okay, so that means my first 2 letters, I can repeat, so I have 26 choices, 26 choices. Now this 4-digit even number, what I have to think about is I have a 4-digit even number. The only thing I have to worry about for an even number is my last digit. Because if I think about 52, the only thing that I have to worry about is this last digit has to be even. If I think about 1026, this last digit is what has to be even. So I have, out of my digits of 0 through 9, my even numbers are 0, 2, 4, 6, and 8. I have 5 choices. So that's going to be 5 choices. That's the only place I have to worry about having an even number. So that's the only spot. So now any other spot, I could have an even or an odd number. And I can go ahead and repeat, so I have 10 choices. And then I multiply all of those together. And when I multiply all of those together, I think I got something like 3,380,000. Now my next one said 3 letters followed by a 4-digit even number with no repetition. So 26, 25, 24. Now a 4-digit even number. My last spot is still going to be 5, but now I used one of my numbers. I cannot repeat. So now this spot right here can't be 10 anymore. I used one of those numbers. So it's going to be 9, and then 8, and then 7. So we're going to go ahead and multiply those. And so now that is, I think, 39,312,000. Okay, our next one. There are 10 sprinters in a track meet. How many ways could they earn first, second, and third place? So I have 10 choices for my first spot, 9 choices, and 8 choices. So this is first, second, and third. And so I would go ahead and multiply. I would get 720. The last one for number 4, it says how many ways can 8 students be put in a single file line? I think that was 8. So in a single file line, I have 8, 7. Now remember, students, I can't repeat. 6, 5, 4, 3, 2, 1. So I could multiply. And so some of you might say, well, can we do 8 factorial? Absolutely. So we could do 8 factorial. Now, the last thing we're going to talk about today is we're going to talk about permutations and combinations. Now, we did the formula for combination when we talked about binomial expansion. So let's talk about that first. Combination is the number of ways to choose a group of subset items from a larger group. And order does not matter. So we know that our formula, we learned this the other day, the combination of n choose r. We could also see it in vertical form, all right, is n factorial over r factorial times n minus r factorial. Now, since order doesn't matter, I'm going to give you some keywords. This is going to be group, committee. I want you to go ahead and write this down. Sample, select, deck of cards. Okay. Now, the difference between permutation is the number of ways to arrange certain items in a specific order. So this is super important. Order matters. So our formula for this The setup is similar. We cannot write this one vertical though. Or we could see it as NPR. Our formula is a little bit easier, n factorial just over n minus r factorial. So you will need to know these formulas. And some keywords are arrange, order, position, schedule. If I say first place, second place, third place. If I give jobs like president, vice president, and so forth, these are just some of the words. Oops. Now, if you have to pause this to write this stuff down, go ahead and do that. And we'll talk about some more of the words in class. So go ahead. Now, what we're going to look at, if we look at these, we know that we can use our formula. We did combinations before, but for permutation, I can go ahead and do the same type of thing. So I can go ahead and do 7 factorial over, this becomes 7 minus 3 factorial. So this is 7 factorial over 4 factorial. And then just like I did before, if I said no calculator, I would do the larger one in terms of the smaller one. And then I would go ahead and I would simplify. And we would have 42 times 5, which would be 210. And then just to refresh for combination, I could do the same thing, 11 factorial over 5 factorial times 6 factorial. And I could go ahead and do 11 times 10 times 9 times 8 times 7 times 6 factorial over 5 factorial times 6 factorial. We could cross that off. And then I could go ahead and multiply through. Let's look at this last one. With permutations, this is very similar to what we've done before with combinations. But this says, okay, we need to go ahead and use the formula. So when we use the formula right here, this is going to be n factorial over n minus 2 factorial equals 56. So what I could go ahead and do is I could go ahead and cross multiply. So I could do 56 times n minus 2 factorial equals n factorial. I'm going to get the 56 by itself. So I am going to go ahead and divide by the n factorial, n minus 2 factorial. So I have 56 equals n. Now I'm going to go ahead and so I have n factorial over n minus 2 factorial. I don't need to show all of these steps, but I'm showing it to you. I'm going to write the larger factorial in terms of the smaller factorial. So I have 56 equals n times n minus 1 times n minus 2 factorial all over n minus 2 factorial. That cancels out. So I have 56 equals basically n squared minus n. So then I have n squared minus n minus 56 equals 0. I'm going to go ahead and factor n and n, 7 and 8. 8 is going to be negative. So n would be negative 7, n would be 8. But remember, we're trying to figure out what n is going to be. Well, n is not going to be a negative number. So in this case, n is going to be 8. So you're going to use the formula in order to solve for n. So you're going to use the formula of permutations, and then you're going to use the formula of factorials. Okay, that is it. Have a great day.